So for this equation, the expression for the magnetic force on a moving charge in the electric field is given by the magnetic force equaling the moving charge times the velocity of the proton times magnetic field. This equation is used because we know that there's a 3D geometric relationship between the direction of the magnetic force on a moving charge and the direction of the applied magnetic field. So next, we know that the velocity of the electron is equal to 2 times 10 to the 7 meters per second times j hat, and the magnetic field is equal to the 3.5 Tesla times k hat. So the product of the velocity plus the magnetic field vectors is given by velocity of the protons times magnetic field equals 7.7 times 10 to the 7 meters. Tesla A over S times I hat. The charge of the electron equals negative 1.6 times negative 19 coulombs. That basically means that the magnetic force of the moving electron is in the opposite direction of the cross product velocity of electrons times the magnetic field. Which overall, this kind of just summarizes the experimental observations of the effect of the magnetic field on a moving charge. So if the charge does move, the magnetic field does not affect on it, whereas the electric field takes effect even at rest. But by substituting the values of the previous equation, we get the force acting on the moving charge following the magnetic force equaling 1.12 times 10 to the negative 11 newtons. So the drawing kind of demonstrates that the force is being along the positive x-axis. And we didn't have to necessarily do a problem for this, but sometimes we may come up. We didn't have to do this particular concept,